equation, but mostly first we're gonna look at the parabola, and then we're gonna look at the key features of the parabola. So what are things that we're gonna be looking for when we're graphing? Okay, we call these the key features. Okay, so there are important points that we're gonna have to look for. So first, a quadratic relation is modeled by a smooth, symmetrical curve known as, what do we call this shape? What do you call this? Parabola. Okay, so the description for it, that it's a smooth, so it doesn't have bumps, right? So it's a smooth, symmetrical because there is a symmetry, right? So I can cut it in half and there is a line of symmetry, okay? Curve, and we call it a parabola. Now in the parabola, we're gonna look for the following key features. So we're gonna look for the zeros, the x-intercept, the vertex, axis of symmetry, and optimal value, okay? So first, when I'm looking at the zeros, when I'm looking at the zeros, where would the zeros be? What does a zero represent?
The point when the curve change.
This
I
is
don't know if I understand zeros.
no. So what you're
Yeah.
pointing at this point.
Yeah.
This is called the vertex.
Oh,
Okay. So the zeros are actually the x-intercept.
Yeah.
Yes, it's the x-intercepts. They're the x-intercepts. Intercepts. Let me just move it. So when I refer to the zeros, I'm referring to this point and this point. Sorry, it's not.
Yeah.
I'm referring to these points. Okay. So x-intercept, or when the graph intersects the x-axis. Okay. Now there is a specific way that we write these. So you can write them in two different ways. You can, like when I asked you to find the x-intercepts, there's two different ways that you can write the x-intercepts for me. One way you can write it as x-intercepts, and then you can say that x is equal to, and then you can state the values of x. Okay, so I'm just gonna use letters here, so we can, I'll tell you later why I'm using these letters, but we go odd and s. So let's say this is, the value of this is r, the value of this is s, okay? So we state them like x is equal r, comma, s, or you can, sorry, not comma, and s. So you have to put the word in. Okay, so if this value here is, if this value here is -1 and this value here is 3, then we can write it as x equals -1 and 3. Okay, this is how you state it.
What's the last one?
-1.
Oh, that's negative. Oh,
Yeah.
sorry.
It's just, sorry, again, like it's not lined up properly, so things get pretty -1 and 3. Okay.
Is it called factoring way?
Yes. So we're going to look at the factored way, but we don't look at the factoring until next unit, okay? But there's three different formats of quadratic. So there's the vertex format, there's the factored format, and there's the standard form. We're going to look at all three of them. First, we're looking at the vertex form, but what I'm teaching you here is all different key points.
R and S, those two letters, we will use it all the time, or?
The reason R and S, this is a general form,
Yeah.
okay? The reason why they're R and S is because our equation that we use has the R and S in it. But when you're stating them, you're going to state the values, okay? So when I say find what are the x-intercept, you're going to look at the values and you're going to write x equals -1, x equals 3. You're not going to use the letters, okay? Now, the other way that you can state it is you can use point format. So you're going to have to pick one of these formats, okay? Or you can state it like this. If I'm asking you for the x-intercept, you can say R0 and S0, okay? So you can state it as points instead of as just x equals to. So the x-intercepts for the zeros are when the graph intersects, or crosses the x-axis. Okay? There's many terminologies that they use for the zeros. So if they're asking you in the question solve, right? When they ask you in the question to solve, that means you are looking for the x-intercept. Okay? So in a question, it could be they can say solve. Okay? When they say solve, you're looking for the x-intercepts. Okay? When they say find the roots, roots is another word that they use for the x-intercepts. Okay? Or find the roots. Okay? So they can use roots, x-intercept, zeros. They can use all these terminology, and they all represent the same thing, which is the x-intercept. Now, for a quadratic, the maximum number of x-intercept you can have is 2. Okay? So when you're graphing a quadratic, you can have the following options. You can have 2 x-intercepts. You can have 1 x-intercept, right? Or you can have no x-intercepts, right? So when your graph is below the x-axis or above the x-axis and opening up, right? Or if I have one right here, right? That's another example, right? So the 3 different options are if you have 2 x-intercepts, 1 x-intercept, or no x-intercepts. Okay? These are the 3 options. So we looked at the x-intercepts. Now we're going to look at the y-intercept. So this is when the graph intersects the y-axis. Okay? So if you look at this graph, this is where the graph intersects the y-axis. Right? So this is where your y-intercept is. This point, you can also, there's 2 ways that you can write this point. You can write it as the y-intercept is at y equal to, and then give me the value. So in this case, we're going to use the letter C, and I'll tell you later why we're using the letter C. Okay.
The x equals 0, right?
This is x equals 0. So that's another way that you can write this, is you can write it as 0C. So you can pick these 2 methods. Okay? So let's say the value here is -4. So you can write it as y equal -4, or you can write it as 0, -4. Okay? So there's 2 different ways that you can properly write this. So the y-intercept is where the graph intersects or crosses the And there's always a y-intercept somewhere, right? Sometimes it's not visible, sometimes we don't see it when we graph, but there's always a y-intercept. Yeah.
Is that great or graph?
Graph.
Graph.
Now we get to the vertex. The vertex is going to be our focus for this unit, okay? And the vertex is a very important point because that's a point where your graph turns, okay? So that's either your maximum point or your minimum point. So basically your vertex is located at the tip or the, I don't know what that is, the tip of your graph. There we go. So this is your vertex, okay? So it's either your max or your min, as you can see in the first graph, okay? So how do we state the vertex? The vertex is a point. The vertex should have both x and y values, okay? The letters we're going to use for the vertex is h, comma, k, and the reason we use the h and k, you will know because then our general form has the h and the k in it, and then we'll talk about it, okay? But we're going to use it now as hk. So if I'm looking at this graph, and I'm looking at my vertex look like it is at 1 and -6, okay? So I can report it like this, okay? Where the x value first, right? Then you write your y value, okay? So 1 and negative, oops. So if I look at this, right, this is 1 and this is -6. Even for this one, I think it's also 1 and -6. Even though it's opening downward, it's still the same vertex. It happened to be. Okay, so the definition of the vertex is the lowest or highest point on the parabola. Are we okay with this? All right. Now, if you are to draw an axis of symmetry, what does axis of symmetry mean? What does an axis of symmetry mean? Symmetry is like when you're when you cut something in half and then when you turn it, like when you flip it in the middle, like when you cut something and then you turn it, it will overlap, right? Yeah.
Is that when you flip the actual thing? Like where you go like this and you go see it?
That's right. So, but we're not going to do that yet. But let's say if I have this paper and I wanted to draw an axis of symmetry, there's two different ways. I can draw a vertical axis of symmetry, and that means I can fold it in half, and then that will fold perfectly, okay? Or you can draw it in the middle like this, and then fold it perfectly, okay? So it's something that cuts your graph exactly in half where it's symmetrical, okay?
How
So,
can I do work?
symmetry.
No, symmetry.
No, symmetry, that's a different one. Symmetrical. That's symmetry right here.
Symmetry, okay.
Yeah.
Symmetrical. That one. That one with C and.
Yeah. Okay? So, if you're gonna draw a line of symmetry here, where would you try it? In the middle vertically? Vertically, like
Yeah.
this way, or do you draw it horizontally? That's my question.
No.
Vertical. So, and then if I'm gonna draw it vertical, what point does it pass through? The vertex, right? So if I'm gonna draw a line of symmetry, I'm just gonna move this to the left a little, to the right a little bit, just because I have more of a grasp on my. So if I'm gonna draw a line of symmetry, I'm gonna have to draw it in the middle, passing through the vertex. Okay? We call this axis of symmetry. So this is why it's called the axis of symmetry. Okay? So it's a line that is drawn vertically in the middle of the axis, and that's why we say it's symmetrical curve, right? It's symmetrical to this imaginary line that we can draw down. Okay? Now, it passes through the vertex. But what part of the vertex does it pass through? The x part or the y part?
The X.
The x. So, the axis of symmetry is, when I report the axis of symmetry, so I use the three letters AOS, okay, because it's at AOS, okay, axis of symmetry. So the axis of symmetry is x equals to, right, because it's a vertical line, so it has an equation of x equal to, okay, and then it's going to be, what letter represents the x value of the vertex?
The H.
The h. So it's going to be x equals to the h. Okay? So in this case, if I'm taking this example, the axis of symmetry is going to be x equals 1. Okay? So always the axis of symmetry is going to be reported as an x equal to, and whatever the x value of the vertex is. So when I report it, it's x equals to the x value of the vertex. Oh, okay? So whatever the x value of the vertex is. Which one? No, that's AO, are you talking about this?
Yeah.
AOS. So axis of symmetry. This is just an abbreviation, so I don't have to write axis of symmetry every single time. Okay? It's the first three letters of the initial. So the axis of symmetry is an imaginary line of symmetry that runs vertically through the vertex. Through is missing an H.
So how can we could we get the result the vertex by that, right? By that equation?
Yes, so we're gonna learn that equation and how can we find it from that equation. Yeah. Okay, but from a graph, you can find it from a graph, right? If I give you a graph, you should be able Now the optimal value, right? An optimal value means it's the best, or it could be the highest, or it could be the lowest, but it's the best. It best represents the situation, okay? So in this case, my optimal value could be either a maximum value or a minimum value. So when I'm looking at the optimal value, I'm looking at the y value, okay? So I'm looking at the y value, okay? So it could be a min, or it could be a max. So if I'm looking at the y value, it's the y value of which point? The vertex. And what's the y value of the vertex? What do we call that? What letter do we represent that? K. So that means the optimal value, we're going to report it as y equals k, whatever your k is, and you're going to tell me if it's a max or a min. Okay? So you're going to say y equals to -6, and it's a minimum, or y equals -6, and it's a max. Okay? It depends if you have a opening up or opening down. So you're going to report that as y equals k, max, or min. Okay? So for the first graph, I am going to say for the optimal value, y equals -6, and it's a min. Okay? For the other graph, I'm going to say for the optimal value, y equals -6, and it's a max. That's or, by the way.
How would be the minimum and the maximum the same number, -6?
It depends if your graph is opening up or opening down, right? So I could have a graph that looks like this, right? And it has a max at, let's say, 4, okay? But I could also have a graph that is opening like this, right? And then it has the same, but it's a min, right? So it's not in the same graph for sure. They're two different graphs. So it's how low